Hello everybody, this is Math 024, Module 5, Video 3, and here we're going to look at applications of systems, so problem solvings with systems. We're going to write the systems and then solve them as well. So in order to, deal with a problem, an application of systems, you always want to read the problem, understand what information is given, and then determine what needs to be solved, and define your variables. So in our case, usually x and y, unless they tell us differently. Then we'll create our system, excuse me, and then we'll solve the system using the most appropriate method. So sometimes our problems lend themselves to substitution, sometimes elimination, and then we'll check our answer, make sure it makes sense, and then label the answers. Like, are we talking about people, dollars? What are we looking for? So the first one is one where we're just writing the system, following the problems written out in words. So I think these honestly are a little bit hard to do. So we're going to start off and we're going to have two variables. We have one number and a second number. So x is going to be the first number, and y will be the second number. So one number, I'm going to say the first number, is 2 more than a second number. So we know that y is the second number, and the first number is 2 more than the second. So to get to y, we're going to take x and we're going to subtract 2, because one number is 2 more than the second. So x is 2 more than y. So x minus 2 will give us y. And then for our second equation, we have twice the first number. So let's do 2x is our equal sign. So twice the first number is 4 less than 3 times the second. So our second number, 3 times the second, would be 3y, and then minus 4. So there are our two equations. And as you can see, this one lends itself to substitution because we have that y equals equation. So I'm going to plug in this x minus 2 where the y is. So we're going to have 2x is equal to 3 times x minus 2 minus 4. And that will give us 2x is equal to 3x minus 6 when I distribute, minus 4. And then when I simplify that, I get 2x is equal to 3x minus 10, because that's plus and negative, so minus 10. All right, and let's see here. I am going to subtract 2x from both sides. So I have 0 is equal to x minus 10, and then I'm going to add 10 to both sides to get x by itself. So here we know that x equals 10. All right, so we know what x is. We got to find y. So let's plug in our 10. So we're going to do y is equal to 10 minus 2, or y is equal to 8. So in this case, our two solutions are x is 10 and y is 8. All right, now we are going to do our next one. Again, this is another one written out in words, the equations. So we have one number and a second number. So I'm going to make x the first number again, and y the second number. So 3 times one number minus a second is 8. So 3 times x minus a second, so minus y, remember, is your equals. So equals 8. And then the sum of the numbers is 12. So that is, sum means addition. So x plus y equals 12. Find each number. All right, so this one's nice because if I look at it right here, I have minus y and plus y. So I can do elimination. I can cancel out those y's. 3x plus x is 4x, and it's equal to 8 plus 12 is 20. So we're going to divide both sides by 4, and we get x equals 5. And then we can go back and we can do, 5 plus y equals 12. So then we'll subtract 5 from both sides, and y will equal 7. So our solution to this system is 5, 7. Okay, now we have, for our next one, we have a plane that travels 560 miles per hour with the wind and 480 miles per hour against the wind. Find the speed of the plane in still air and the speed of the wind. So we have to find two things, the speed in still air and the speed of the wind. So let's make x equal to the still air speed. And then y will be the speed of the wind. Okay, so the first equation is the plane travels 560 miles with the wind. So with the wind is really going to mean like you're going to take the still air plus the speed of the wind because it's going with the wind, and you can travel 560 miles per hour. Now it travels 480 miles per hour against the wind. So that means we're going to take that still air and it's against it. So you're going to subtract the wind speed because you're really kind of going into it. So it's going to take it, it's harder to go. So it's going to be 480 miles per hour. Again, this one is perfect for elimination because if we add it together, those y's cancel out. So we have 2x is equal to 1,040. Divide both sides by 2. So x is going to equal 520, and that will be the still air speed, so 520 miles per hour, and that is in the still air, so if there's no wind resistance. Now let's find y. So, again, I'm going to go up to this equation, I think. So I'll do 520 plus y equals 560. And we'll subtract 520 from both sides. So y is equal to, not 500, excuse me, 40. And this will be 40 miles per hour. And this is the wind speed. And you do want to make sure you label your answers. We can still write it as an ordered pair. So 520 and then our 40. And that's it for that problem. All right, so number 4 is very similar to the one we just did with the air current or the wind speed. Here we have water current. So Bob can row 10.6 kilometers with the current and 6.8 kilometers against the current. Find the speed he can row in still water and the speed he can row with the speed of the current. So find the speed of the current and how fast he can row in still water. So again, let's define our variables. Let's make x the still water, and y will make it the speed of the current. Okay, so let's see here. Just like we did before, Bob can row with the current 10.6 kilometers. So again, let's do x plus y equals 10.6. And against the current, x minus y equals 6.8. And we can do, again, our elimination here because our y's cancel. So we have 2x is equal to 17.4 when we add it together, divide by 2. So x is going to equal 8.7. So that will be the speed of the current, or excuse me, that would be the still water, how fast he can row in the still water. So he can go 8.7 kilometers with the current, or in the still water. And then let's find the speed of the current. So we'll do 8.7 plus y equals 10.6. And when I subtract 8.7 from both sides, I get y equals 1.9. So the speed of the current is 1.9, let's say, kilometers. And again, you can write it as an ordered pair, so we can do 8.7, comma, 1.9, and there we go. All right, next, for number 5, we are going to look at an office supply store sells 7 writing tablets and 4 pens for $6.40. The same store sells 2 tablets and 19 pens for $5.40. So they want us to find the price of 1 tablet and 1 pen. So our 2 unknowns are the tablet and the pen. So let's make x equal to the tablet. And we'll make y equal to the pen. So let's see, the first equation would be they sell 7 writing tablets, so 7x plus 4 pens, so 4y, for $6.40, so equals $6.40. Then our second equation is 2 tablets, or 2x, plus 19y equals $5.40. All right, so let's see here. We need to solve this. And probably looking at this, I think elimination would be the best. And I think I'm going to focus on the x's because I have 7x and 2x, and I know a common multiple of 7 and 2 is 14. So I'm going to make one positive 14, one negative 14. So I'm going to multiply everything in the first equation by 2 and everything in the second equation by negative 7. So my 2 new equations are going to be 14x plus 8y is equal to 1280, or 12.8. And then negative 14x for the bottom, plus negative 7 times 19 is negative, let me erase this real quick, negative 133y, and it's going to equal, we're multiplying by 7 there, so negative, or negative 7, so negative 37.8. All right, let's add our equations together. The x's will cancel. I end up with negative 125y equals negative 25. We'll divide by 125, negative 125. And so we get y equals, 2 negatives make a positive, which is good because we're talking about price. So we get 20 cents. So each pen is 20 cents. Now we need to find the cost of a tablet. So let's go to our first equation. I'm going to do 7x plus 4 times 0.2 equals 640. And it doesn't matter which equation you choose again. So 7x plus 0.8, or 80 cents, equals 640. Subtract our 0.8. or 80 cents there. So 7x equals $5.60 or 5.6 divided by 7. So x equals 0.8 or 80 cents. So that means each tablet is 80 cents, each pen is 20 cents. And again, we can write it as an ordered pair to show our solution. But we're talking about money for each, so they're each 20. The pens are 20 cents and the tablets are 80 cents. All right, so for our next one, it's going to be similar to the one we just did in number 5. A theater sells adult and child tickets at different prices. 3 adult and 4 children tickets cost $159, while 2 adults and 3 child tickets cost $112. Find the price of 1 adult ticket and 1 child ticket. So again, we're going to define X and Y. I'm going to make X the adult tickets and Y the child ticket, or the price of them. So for our first equation, it's 3 adult and 4 children's tickets cost $159. So we're going to do 3x plus 4y equals 159. And then the other one is 2 adult and 3 child tickets cost $112. So 2x plus 3y equals 112. And again, I feel like with this one, the best way to solve it is through elimination. And we can turn the x's into 6, because that's a common multiple of 2 and 3. So I'm going to multiply the top by 2 and the bottom by -3. So my new equation will be 6x plus 8y equals 318. And then we'll have -6x minus 9y equals -336. And when we add them together, the x's cancel. We have -1y is equal to -18. So to solve this, we're just going to divide by -1. So y equals 18, or the price of a child's ticket is $18. Now let's find our y by substituting into one of our equations. So we'll take, and I'm going to go to the original, 3x plus 4 times 18 equals 159, or 3x plus 72 equals 159. And then subtract 72 from both sides. So we get 3x equals 87. Divide by 3, and x is 29. So it's $29 for an adult ticket and $18 for a child's ticket. So again, if we wrote it as an ordered pair, we do 29, 18, and there we go. All right, next we are going to do a problem where it is going to be, it's a mixture problem. So it's a little bit different than the ones we've kind of been doing, but not horrible. So we have a grocery store that sells M&Ms at $2 per pound and trail mix for $1.50. So we want to know how many pounds of M&Ms and trail mix should the manager mix to get 50 pounds worth $1.80 per pound. So we got to define our two variables. We're going to make x be our M&Ms and y will be the trail mix. Okay. So when we're writing our equation here, first thing we want to know is they want to get 50 pounds worth. So they want to mix a certain number of pounds of M&Ms plus a certain number of pounds of trail mix to get 50 pounds. So, this is the weight of the M&Ms for X and the weight of the trail mix for Y. Now, the other equation that we're going to write here, this one's going to deal with the price. So we know that it's $2 per pound. So we're going to do 2 times X plus it's $1.50 or 1.5 Y. And then we know that it has to equal $1.80 per pound, but they need to have 50 pounds. So this is where it's a little bit different. We're going to put our 50 times our 1.8 here, or the cost. So when we multiply out that 50, we are going to end up with, and I'm going to rewrite it, so we're going to have X plus Y equals 50, and then 2X plus 1.5Y is equal to 50 times 1.8 is 90. So now to solve this, we could do either substitution or elimination here. I think it's a little bit easier to do elimination, so I am going to just make this a -2 for the X. So I'm going to multiply everything there by -2. So it's going to give me the equation -2X minus 2Y equals -100. And then on the bottom, we'll keep our 2X plus 1.5Y, 5 there, equals 90. So we didn't do anything to that bottom equation. My X's will cancel. I'm going to have, when I add -2 plus 1.5, so it'll be -0.5Y is equal to -10. And I'll divide by -0.5. And we get Y is equal to -10 divided by -0.5 is going to give me +20. So 20 pounds of trail mix is needed. And then we got to find Y. So if we go back to this equation, make it easy, X plus 20 equals 50. So we plugged in our Y. Subtract your 20. So we know that X is going to equal 30. So we need 30 pounds of M&Ms and 20 pounds of trail mix in order to make a 50-pound mixture that's worth $1.80 per pound. Kind of cool to think about it and do this to figure that out. Okay, here's our last one, and it is similar to number 7 that we did with the mixture, except now we're dealing with percentages of a solution. So a pharmacist needs to prepare 12 ounces of a 9% solution. She has a 4% solution and a 12% solution available. We need to find how much of the 4 and 12% solution she must mix to get 12 ounces of the 9% solution that she needs. So our X and Y are going to be the solutions that we have. So X will represent the 4% solution. And again, we're figuring out the amount. And Y will represent the 12% solution. Okay. So again, when we're writing our system here, just like we did with the mixture of the M&Ms and trail mix, the first thing is we need to know how much she'll need of the 4 and 12% to get 12 ounces. So the first equation is just going to be X plus Y equals 12, because that's how many ounces we need together. We need to mix together a certain amount of ounces from the 4%, a certain amount from the 12% to get 12 total ounces. Now, the other part is just like we did before. Now we're going to look at the percentage, not the cost. But a 4% solution, remember, as 4% as a decimal, you move that decimal point 2 places to the left. So it's going to be 0.04x plus 12% is 0.12 as a decimal, so 0.12y. And then here again is where we need to multiply together. We need 12 ounces, but it needs to be in the 9% solution. So that 9% is 0.09. So we're going to do 12 times 0.09. And that is going to leave us with our equation of x plus y equals 12.04x plus 1, or 0.12y equals, and we would do 12 times 900, so we get 1.08. This problem, I'm definitely going to do substitution here, because I think turning it into problem, or multiplying it to make it add up to two terms that cancel out is a little bit more complicated. But I can take this x plus y equals 12 and solve for either x or y. It doesn't matter. Let's solve for y. So I'll subtract x from both sides. So y is equal to 12 minus x. So now I'm going to plug that into my bottom equation. So I'm going to have 400x plus 1200, and instead of y, I'll put times 12 minus x equals 1.08. When I distribute, I get 400x plus 1.44 minus 0.12x equals 1.08. And now combine your like terms. So negative 0.08x plus 1.44 equals 1.08. And then I would subtract the 1.44 from both sides. And when I do that, I'm going to move into black up at the top because I'm running out of space. When I subtract 1.44 from both sides, I get negative 0.08. Sorry, my pen is not writing very well today. X is equal to negative 0.36. Divide by negative 0.08. And we get x is equal to 4.5. So I need 4.5 ounces of the 4% solution. And then if we solve and I go, so x is 4.5, so 4.5 plus y equals 12. Subtract 4.5. And we find out that y is going to equal 7.5. So we need 4.5 ounces of the 4% solution and 7.5 ounces of the 12% solution. And you'll find these mixture problems, you set them up the same way each time. So like the M&Ms and the trail mix, even though they were different than the percent solutions, they were set up the same way. And they're kind of cool to solve. I think they're, could be useful for you in the future. I know I have a lot of pharmacy techs that take this class. So this is it for Module 5, the last video for the section, and this is it for the videos for 0 to 4. Have a great day.